Whenever you need to travel a great distance, such as from one country to the other, you book your airline flight and anticipate being in the air for several hours. When traveling across space, though, you must move quickly because all of the things of attraction are further away. Space explorers have always been on the lookout for a technique to travel faster than light in order to reach deep space faster. All of the ways revealed so far have serious flaws, but scientists have discovered a new approach. How does it function? What are the conditions? When will you be able to use it for travel? Join us as we introduce a revolutionary method of traveling faster than light. Light is intriguing and crucial since seeing this film would be tough without it. We could walk without crashing into objects because of the sun and various artificial light sources that people have devised. However, you've surely heard that light travels quickly. But how quickly does light travel? Surprisingly, the precise speed of light is known and serves as the foundation for most other calculations. The speed of light in a vacuum is 299,792,458 meters per second, or 983,571,056 feet per second. In 1 second, the light will travel around 186,282 miles. When you turn on a light bulb in a dim room, the light covers the space almost immediately, and you won't notice. The light year is yet another unit of measurement that involves light. It represents the distance that light may travel in 1 year. This figure is approximately 6 trillion miles or 10 trillion kilometers. Astronomers and scientists use it to measure vast distances throughout our cosmos. As previously said, the cosmos is so enormous that light may travel thousands of years from one end to the other. For example, light travels out from the moon to our eyes in roughly 1 second, implying that the moon is 1 light second away. However, sunlight takes longer to reach our eyes, taking roughly 8 minutes, implying that the sun is just about 8 light minutes distant. The light from Alpha Centauri, our closest star system, takes around 4.3 years to reach us. Therefore, Alpha Centauri is 4.3 light years distant. Other stars and things outside our solar system can be found from just a few light years to billions of light years away. This is why what astronomers see to the farthest reaches of the cosmos is history. When they investigate distant things, they perceive the light that depicts the items as they were at the time the light left them. While there are many amazing things that light can accomplish, scientists have attempted to journey at the speed of light. This is fascinating since humans will soon be an interplanetary species. For example, Elon Musk, the wealthy CEO of SpaceX, wants to establish a civilization on Mars. But his explorers will have to endure at least 5 months of space flight before landing safely on the red planet. Depending on how near the two planets are, this might last up to a year. And that's without even considering the dangers it poses before landing on Mars. With the speed of light, they can complete the journey in far less than 4 minutes. Researchers have explored a variety of approaches to create extremely fast travel. However, there was always an issue that no other approach could fix until a scientist presented the new discovery we'll show you in this video. It's difficult to accomplish even 1% of the speed of light, which is still very fast because it can transport you from Los Angeles to New York in less than a second. In a single word, the issue is energy. The motion of everything generates energy, which physicists refer to as kinetic energy. To accelerate, you must increase your kinetic energy. The issue is that increasing speed requires a lot of kinetic energy. It takes 4 times the energy to make anything go twice as quickly. Increasing the speed of something by 3 times needs 9 times the energy, and so forth. To accelerate a 110-pound adolescent to 1% of the speed of light, for example, would require 200 trillion joules. That's about the same quantity of electricity as 2 million Americans consume in a single day. Consider the M drive, which was built as a device that would whisk humanity to the furthest reaches of the cosmos in record time. Theoretically, this patent-pending technology works by confining microwaves in a structured chamber, where their bouncing creates propulsion. The chamber is closed so it will appear to move with no fuel input or thrust output from the outside. The M drive is based on Newton's second law, which states that force is defined as the rate at which momentum changes. As a result, an electromagnetic wave moving at the speed of light does have a certain momentum which will transmit to a reflector, producing a little force. The M drive, which seems simple yet flips our knowledge of physics on its head, is enabled by this accumulated small force in large quantities. There is no energy moving in or out, which leads us to wonder how the waves begin to move, how they continue moving, and where their impetus comes from. Without an explainable push, you can't have spontaneous, produced momentum, which is why so many scientists dismiss the M drive. If the M drive works, it calls into question a lot of what physicists think they know about the cosmos. Physicists from the Dresden University of Technology put the M drive to the test, revealing that the optimistic results obtained by NASA and the Chinese demonstrating thrust all were false positives explained by other influences. However, as Dr. Eric Lentz, a physicist with over 10 years of expertise in practical applications, has demonstrated, the warp drive has immense promise. Lentz wasn't the first person to try to make the warp drive a reality, and not only in science fiction. Miguel Alcubierre, a Mexican mathematician, was the first to attempt it. His idea became the first formal literature on warp drives in 1994. Unfortunately, the so-called Alcubierre warp drive needs a massive quantity of energy, as well as the feared exotic matter as a co-ingredient. This extremely radioactive substance is solely theoretical and has never been detected in nature, let alone manufactured by scientists. Since then, a few variants have been proposed, including a 2010 upgrade to the physical design of the Alcubierre drive by retired NASA engineer Dr. Harold G. White, Sony. His revision decreased the necessary energy to a more manageable level, yet it was still impractical because the method still required exotic matter, albeit in fewer quantities than the Alcubierre system. Another group of Swiss researchers called Applied Physics, or APL, proposed their idea. Interestingly, their warp bubble was created without the use of any unusual materials. Their model, however, was unable to move faster than the speed of light, which is the pinnacle of space travel. To demonstrate how this approach differs from others already offered, Lentz begins by describing the physical structure of the traditional Alcubierre drive, which is the foundation for practically all other solutions. The Alcubierre method, he claimed, gave an intuitive image of what a warp drive would do: constrict the space directly in front of the center region housing the ship or vehicle, and extend the space instantly behind it. This depicts the warp drive as a curved wave that the spacecraft will travel to its destiny on. Despite the fact that it is the foundation of warp travel, Lentz contends that it is not even the most important aspect. Instead, he claims physicist Jose Notario's answer from 2002 demonstrated that the extension and compression were not required to move the ship ahead. That work led him to reconsider how warp may be formed using simply ordinary matter rather than unusual materials. Notario demonstrated that the expansion might be simple or zero everywhere and yet move a ship. This is a big accomplishment since it eliminates the necessity for exotic matter, which warps the space in front of and behind the theoretical passenger in practically all theoretical warp drive methods. Lentz produced his own variant based on Notario's idea, which he says is even more realistic because it is based on common physics. Aside from this important material distinction, Lentz claims that his solution varies geometrically from Alcubierre's and most others because of how the energy is distributed across the warp bubble. The energy content and curvatures are maxima separated in the Alcubierre solution, with the energy constrained to a tiny torus between the zones of intense contraction and expansion. In Lentz's concept, the curvatures and sources are closely connected, with both the areas of high energy density and high expansion and contraction virtually perfectly overlapping. Because of the geometric differences between his notion and existing conceptions, Lentz's approach might be a more practical warp solution than those previously offered. Of fact, Lentz's warp drive is still only a concept. He does, however, see a few immediate measures that may be done to bring this model closer to reality. One of which, like all prior drive hypotheses, is to reduce the amount of energy required. From here, where does Lentz plan to take his warp drive? He claimed the next goal is to use a modern-day fission reactor to create a warp bubble capable of traveling at 1% the speed of light. The physicist stated he would explore patenting his warp drive, but he stressed that his work is just one component of a broader, fast-developing body of work on this subject, and that the recent growth in new warp drive concepts since Alcubierre's 1994 proposal offers many in his field optimism that a genuine, tested version may be closer than we believe. It's been wonderful to see how far warp drive research has progressed recently, according to Lenz. He believes that many more advancements are possible, and he is forward to seeing what the next several years bring. Let us know what you think about the speed of light in the comments below. And quit being sluggish because it's time to put your intellect to work. Welcome to Technology Zone, where you'll find fascinating information from the past, present, and the future, from the grandeur of nature to wild creatures and amazing truths. Subscribe today, and you will never be disappointed.